My name is Jim Rawson, and I'll be giving the webinar today. First, we'd like to acknowledge that the webinar is funded by a venture fund grant from the AUR that is provided to the Radiology Alliance for Health Services Research, RASER, and the Radiology Research Alliance, RRA. So thank you to the AUR Research and Education Foundation for their support. And what I'm going to be talking about is data visualization. What we're going to do is we're going to look at some common ways to display data, and we'll talk a little bit about some of the pitfalls and challenges when trying to make choices on how your data is displayed. And also I'll provide a number of resources and references that you could use if you want to learn more about some of these data display techniques. So first, when we talk about data visualization, what are we talking about? And what we're usually talking about is a graphical representation of information. So we have some information that we want to display in a way that conveys a message or that allows for interpretation or analysis in an easier way than just putting the information in another format. So why should we invest time in learning about different ways to visualize data? Well, one thing to remember is that it's been said that a picture is worth 1,000 words. And if you can take your 1,000 words and convert that into a single picture and convey all of the meaning that was in that 1,000 words in one picture, that's a much more efficient transfer of information and of understanding. The other thing that can be helpful with data visualization tools is they may be helpful in bringing out or demonstrating relationships or trends or patterns that weren't obvious by looking at the data in a different format. And as the amount of data that becomes available to us increases, whether that's in our electronic health records or our PACS systems, or in social media, or in any of the personal Internet of Things monitoring devices that are being developed, all of that data just continues to increase. So as we have an increasingly large amount of data, one thing data visualization can help us do is potentially condense some of that large pile of data into a single image or a series of graphs or charts that might be helpful in displaying the information in a more condensed form. And this is not a new concept. If you go back to 1854, Dr. John Snowe was analyzing the cholera cases that were occurring in London, England. And what he did was take a map of the streets of London, and he put a black bar at the address of the person who had died from cholera. And he kept track of the cholera deaths, and he mapped them in the city. So this map shows you there's a concentration, and I'll blow that up for you. You can see that the concentration actually is around one pump that's on Broad Street. And a large number of people died of cholera who were going to that pump and getting water. And that was how he was able to localize the cholera infection in the City of London, by using a graphical display technique. Another powerful use of imaging or data visualization technique can be to make a point. So if I tell you that when I was in training, a CT scan of the chest had 20 images, when I was in residency it had 200, and now it has 2,000 images, you might accept those numbers as getting bigger, but you might not have the same feel for just how many more images just from the numbers. But if I showed you the images themselves and showed you what a CT scan looked like in 1980 and 1990, and now in 2 decades later, how many images that actually is represented in a large CT chest study, you now get a better sense of how I'm having to interact with the data differently. Now, one of the challenges is that in any image, not all of the data that's there is signal. Some of that data could be noise. And that noise is something we'd like to minimize. So the next time you put a presentation together, you may want to review your slides from the perspective of how much of your presentation is actually noise. And one way to look at that is what parts of your presentation don't contribute to your message. So if we look at the next slide, these are just some examples of noise, and some people will call this optical clutter. And you can see in the first bullet that optical is put in italics and it's underlined. Another term is chart junk, and you can see that each of the letters is in a different color. And if I ask you if there's a significance to those colors that helps you understand the word chart junk, that's where I'm investing more time and energy in noise of my image or noise of my data than actually presenting the data. And there are other ways that you can add to a presentation that, while perhaps attractive or interesting, may not actually add any additional useful information to the presentation and may not convey additional information. So as we put our presentations or our data visualizations together, we want to try and reduce noise and reduce distractions from the data. There are several ways to think about presentation types. You could be comparing data, you could be looking at composition or distribution of data or relationships between data points. And based on the type of presentation that you're trying to make, there are going to be a number of different types of charts or graphs that you could choose from, each one of which will display the data to a particular advantage if that was the right mapping of your data to your chart choice. So how do you make a decision on what data tool or what data visualization tool to use when you have data? Well, it's helpful to know what your data consists of and what you're trying to do with it. So one question you might ask is how many variables that you have and how many data points are in each variable? And what's changing? Is there a change that you're trying to look for between groups or a change over time? And these questions then you can translate into chart choices. So if you had data that you were trying to demonstrate a trend or change over time that was continuous, a line chart would be a very good choice. If, on the other hand, you were trying to demonstrate comparisons, then a bar chart would actually help you. And if you were looking at the composition or proportions demonstrated by your data, then a pie chart would be a good choice to use. Scatter plots we often use to try and demonstrate a relationship between variables. So what I'd like to do is just show a couple of examples of charts. This first one is a line chart, and you can see on the x-axis that we have year and months broken down, so that's the time axis. And then we have volume of CT scans or number of CT scans on the y-axis. And we're looking at variation over time in the number of CT scans performed per month. And this is actually just sample data. This isn't data from any particular hospital. Let's look at another data visualization. And this is sample data, just looking at delays in starting your CT scan. And what you see is a bar graph, and the bar graph demonstrates the number of counts or number of incidences where a delay was caused by this specific reason. And the tall bar is actually transport in this sample data set. There's another way to organize your bar graph, which is called a Pareto chart. And the same data I've just reformatted into a Pareto chart. And so while the Pareto chart does have the bar graphs are actually ordered from the highest contributing variable to the lowest contributing variable. And then superimposed is a line graph. and that line graph actually adds up each of those causes until you get up to 100%. And this is called a Pareto chart. And this is a tool that's used a lot in presenting quality data. Let's say you had a residency program in a hospital, and you wanted to understand how big your residency was compared to the other residencies in the program. So you could look at the total number of residents, which in this sample data is 175 residents, and you could look at the distribution of residents amongst several different disciplines within the center. And this is a pie chart. So again, when you're thinking about what type of tool to use, you want to try and decide if you're making a comparison or trying to demonstrate a relationship or look at the composition, or if you're trying to look for a distribution. And if you can get into those broad categories, there are tools available, like this tool, where you start in the center and you look to see whether you're trying to demonstrate, say, a relationship or a comparison. And then this particular tool marches you down through several choices to get you to a data visualization tool that you could use for your data. And if this is helpful, this is actually available on the web from Abella at the website that's here at the bottom of the slide. And this is a helpful way to choose a chart or get a chart suggestion. Or you could actually look online, and there are a number of websites now that you can go to where when you make those same types of choices, what type of visualization do you want for your data, then it'll point you towards a particular graph or a particular tool to plot and demonstrate your data. If you're interested in reading more about charts and what chart is the right choice for what you're trying to do, Tableau has a document online on their website which is called What Chart or Graph is Right for You, and it goes through a number of commonly used charts and talks about what they're good to use, in what cases they're the best choice or a good choice for you. Also online, you'll find a variety of tools where you could upload your data to make a chart or a display. There are a number of websites now where you can upload a spreadsheet that will convert your spreadsheet into a map, as is the case on this example. Another map-making website is here, and again, you can import data to be able to have it converted into a map. Word clouds is another way of displaying data, and you can take a document and analyze it for word frequency and then have that actually formatted into a word cloud. Using R, which is a statistical computing tool, there are also some plotting tools here that you could use. If you're familiar with R or you wanted to learn more about it, you could go to the R project website. And there are a lot of other tools online. This is just a sample listing where you could go to these websites and look to see what tools are available for reformatting your data or your message into some type of infographic. And another resource for learning more about data visualization is looking at Coursera, which is one of the online one of the online MOOC courses. And you can see, just looking at the Coursera website, that there are courses on data science and data visualization that you could actually use as a starting point, or in some cases to build on existing skills with more advanced courses. Finally, there are some individuals who really have made significant contributions in data visualization and either run courses or have published books. I've listed 3 of them here and their websites, Edward Tufte, Stephen Few, and Hans Rosling. And each of them has a way of viewing data and presenting data that's rather unique and is helpful to look at in terms of trying to advance your data visualization skills. Well, that concludes our webinar for today, and I hope that's been helpful for you. And again, want to thank the AUR-RNF Foundation for support of the webinar series. Thank you very much for your attention.